All right. Find the largest rectangle formed from the origin to a point on the parabola y equals negative x squared plus 2x plus 9 in the first quadrant. You see this is concave down. It opens downward. We see that the y-intercept is 9. Maybe you've forgotten which way it shifts. It really doesn't matter. Because what we care about in the broadest sense is that we have a vertex on the origin, and then we have some sort of parabola, and I'm not going to go anywhere outside the first quadrant, and the other vertex has to be somewhere here. And I want to maximize that rectangle. Everybody, this is actually a plenty good sketch of what's going on. All right? And the hardest part for students usually here is the thought of, well, this point is x, y. Do you guys agree the rectangle is x by y? All right. Just for some pre-calculus review, I did up where this is and did a little nicer picture on the other page. Let's go through that just super fast. It would be a pain, but we could space out the plus 9, right? Factor out the negative, complete the square, and find that the vertex or the vertex of this parabola is at 110. It doesn't even change the problem, though. Do you guys agree that the largest rectangle is probably somewhere about right there? We'll make the point plenty big. We don't, and this point is xy. And even if you make a great picture this time, does everybody agree the rectangle doesn't change? It's x by y. So whether you have this crappy picture over here or this beautiful picture over here, it doesn't matter much. If I finish this problem now, and I like the pretty picture, especially for YouTube. So I do this. Everyone, we have to write some equations. Well, what do I want to find? I want to find the area of the rectangle. What is the area of this red rectangle? xy. Does everybody agree with the area equals xy? I want to optimize A. I want it as big as possible. But if I'm going to optimize A, I can only have one variable on the right side. So I need to pitch either x or y. Yeah, it screams, let's get rid of y, because y equals this stuff. Now, you might not like this equation. All right? You might not like this equation. Like being at school when we should have had a snow day. All right? But we're here, so we're going to continue on. Everyone, you distribute. And everyone, you look at this. This is an easy derivative. This is an easy derivative. So take it. A prime equals negative 3x squared plus 4x plus 9. Now, this is what you guys hate. This is going to take some pre-calculus, okay? Because I'm going to set A prime equal to that class where we learned all this stuff. I'm going to set this equal to 0. And I'm going to put this equation equal to it. Now, everybody, you could use the quadratic formula, right? Which we're not, Juda's, we typically don't. I like completing the square. I think it's faster. I divide by negative 3. All right. I'll bring the 3 over, send it packing. I know I'm going to get x minus 2/3 squared. So I'm going to add 2/3 squared is 4/9. I'm going to add 4/9. And I'm going to get 3 plus 4/9 is 3 4/9. So I'm going to write this as 31/9. Take the square root of both sides. And I get x equals 2/3 plus or minus the square root of 31 over 3. And you guys might hate this answer. Well, here's the problem. First of all, I lock this in. If we go back to a single page, I lock this where? I lock this whole problem into first quadrant. 2/3 minus is not in the, can't be that. So everybody, I could use the first derivative rule and check, but I don't need to. I know this is the maximum by my drawing, right? And everyone, find the largest rectangle. Well, here it is. X is equal to 2/3 plus the square root of 31/3 over 3 is the x coordinate. How would I find the y coordinate if I had to? I would have to go back up and find the y here if I wanted to find the y coordinate. But I didn't ask for that, did I? I said find the largest rectangle, which means I'll have to plug this into this one. Area is equal to negative x cubed plus 2x squared plus 9x. Everyone, do we want to plug in a two-term thing like this in that equation? I don't. So what I'm going to do at this point is use my calculator and literally take what's the value of 2/3 plus 2 divided by 3 plus square root of 31 divided by 3. And I get that this is 2.5226. That is my x-coordinate. 4 decimal places. 4 decimal places. Everyone, if I want to find the area, I've developed the equation. Now I can just plug it in. And I'm not going to write it out. I'm literally just going to put in 2.5226. And this is where knowing your store key helps, okay? But if you don't know where it's at, and I'll pause. And when I plug that in and I do all the plugging and chugging, I get 19.3778 units squared is the area. And everyone, if we go back dual page just for a second, 19.3, we'll call it 19.4 as we think about it. If I look at this picture, I can believe 19.4. 3 by 6-ish would be the largest rectangle. And again, is what's happening now in calculus is we are leaving integers behind, right? When you think about that x value, 2.5226 is not very pretty. And there's really, you have to use your drawing to get a semblance about whether or not they're the correct answers. But on the optimization side, going back to the top, we had a picture, right? We actually made a good sketch, but a rough sketch led to A equals XY. Realize this is not related rates. This is not gallons per minute. This is not miles per hour. This is not feet per second. So it's make the largest rectangle, and when you have two variables, we have to get to 1. That is always the hardest part of these problems. Keep practicing.